Hi, welcome back to my YouTube channel. In this video we're going to see how we should solve this integral e to the negative x sine x over x dx. So we're going to use the Feynman's technique for this. And I'm going to define f of t, a function, to be the integral from 0 to infinity of e to the negative x t sine x over x dx. And if I find the f of 1 here, I'm going to be getting the integral from 0 to infinity of e to the negative x sine x over x dx. So my goal here is to find the f of 1. Let me just create more space here for the future work. So my goal here is to find the f of 1. And for that, I'm going to take the derivative of f of t. So it's going to become f prime of t. It's going to be dtt of the integral from 0 to infinity of e to the negative x t sine x over x dx. And f prime of t of mine is going to be the integral from 0 to infinity of, this is going to be moving to the inside of integral, and it's going to be partial derivative. So it's going to be partial t of e to the negative x t sine x over x dx. Now my f prime of t is going to be the integral from 0 to infinity of negative x e to the negative x t sine x over x with respect to x, and these negative x's and x are going to be cancelled out. These two are going to go away, and it's going to be leaving me with f prime of t b is equal to the integral from 0 to infinity negative x e to the negative x t sine x dx. Now this integral is solvable. If you remember the integration by parts, if I have u dv, it's going to be uv minus v du. So we use integration by parts. So my u here is going to be negative e to the negative xt, thus my du is t e to the negative xt. My v here, my dv here is is sine x dx, thus my v is negative cosine x. My f prime of t therefore is e to the negative xt cosine x, the integral from 0 to infinity, minus 0 to infinity negative cosine x t e to the negative x t dx. Now this f prime of t is going to be resulting in 1 if you calculate this limit. Cosine of 0 is negative 1, so it's gonna be resulting in cosine of 0 is 1, and it's minus 1 because if you calculate this limit, e to the negative infinity is 0. Cosine of infinity, it doesn't matter. It's going to be 0 minus e to the 0 cosine 0. It's going to be negative minus 1. So it's going to be minus 1 minus plus t, the integral from 0 to infinity, e to the negative xt cosine x dx. My f prime of t therefore. So my f prime of t, again, I'm going to take the integral of this one. It's going to be t. If you do the integration by parts again, let me remind you just, so let me just erase it and remind you the work we have to do. We have to define u and v here. My u here is going to be e to the negative xt. My du is negative t e to the negative xt dx. My dv is cosine x dx. My v is sine x. Thus my f prime of t is negative 1 plus t times e to the negative xt sine x, the integral from 0 to infinity, minus plus integral from 0 to infinity, t is going to be here, e to the negative xt sine x dx. my f prime of t therefore is going to be negative 1 plus t times, it is going to go down to 0, this limit, plus t, the integral from 0 to infinity, e to the negative tx sine x dx. And if you remember, this is just the negative of the f prime of t we defined here, so it's going to be negative 1 plus t times negative tf prime of t. It's going to be negative 1 plus minus t squared f prime of t. F prime of t is equal to this thing here, and if I move it to this side, it's going to be f prime of t plus t squared f prime of t equals negative 1. If I factor out f prime of t, it's going to be 1 plus t squared equals negative 1. Thus, f prime of t is going to be negative 1 over 1 plus t squared. Now, I am going to integrate both sides of this thing here, negative 1 over 1 plus t squared dt. This is the antiderivative of this thing is arctan of x. Thus, it's going to be negative arctan of t plus c, some constant of integration. And our work here is to find c. What I'm going to do here is I'm going to equate it to f of t here that I defined, the integral from 0 to infinity e to the negative xt sine x over x dx equals to negative arc tan of t plus c. If t approaches infinity, I'm going to get the integral from 0 to infinity e to the negative infinity sine x over x dx equals to negative arc tan of infinity plus c. This is going to go down to 0 because e to the negative infinity is 0. So 0 equals arctan of infinity is negative pi over 2 plus c. Thus my c, the constant of integration, is pi over 2. So now I'm going to define my f of t to be negative arctan of t plus c, some constant of integration, which is in this case pi over 2. And remember, we were looking for f of 1, which was the integral from 0 to infinity e to the negative x sine x over x dx. We defined the f of 1 to be this one. Thus, if I find the f of 1, if I plug in t equals to 1 here, I'm going to find negative arctan of 1 plus pi over 2, which is going to be arctan of 1 is pi over 4, which is negative pi over 4 plus 2 pi over 4, which is pi over 4. My f of 1 is pi over 4, therefore, since my f of 1 is equal to this thing here, integral from 0 to infinity of e to the negative x sine x over x dx, it is going to be equal to the neat result of pi over 4, and it has an exact value, and it is calculated only by Feynman's technique and no other technique here. So thank you for watching my video. This was a little bit of hard work here, but hopefully you've understood most of the things that I did here. If not, please let me know in the comments, and I'll see you next video.